Compare the total energy output from a team of 4 oxen to that from a ton of wood over the period of 1 year. Assume that oxen can typically deliver 0.8 of a horsepower, and they're available to work 4 hours per day on average 300 days out of the year. The ton of wood equivalent is 9.83 times 10 to the 9th joules. So we're asked to compare two energy sources. One is the amount of energy the total energy that oxen can deliver over a work year. They're not available for that full year, so we need to calculate it for just the time that they're able to work. And then of course there's energy stored in the chemical bonds inside of the wood, and we want to calculate how much is there. The energy in the wood was given to us in 9.83 times 10 to the 9th joules. So it makes sense to just go ahead and stick with joules for this calculation. Joules is the SI unit, and so we're going to go ahead and calculate the energy output of a team of oxen over the course of a year. So a little bit more complicated, but if you're understanding the relationship between energy and power and time from the previous homework problems, this one should make sense. So we have givens. The first is that we were told what the HP, the horsepower of an oxen, was. So the horsepower, or P, of an oxen is 0.8 horsepower. You might want a P of an ox. Maybe not something you thought you'd ever know. We also want to know how much time the oxen are able to work for. That was given to us in kind of a roundabout way. 300 days per year. So every year they can work 300 days. And then, but they can't work the full day, they get tired. So 4 hours per day was given to us. So a little bit roundabout way, we can see that that's going to allow us to calculate the number of hours per year the oxen are available for, and that's just 1,200 hours. Right. We were told that we have 4 of them, so there are 4 oxen total. I don't have a symbol for that. I don't know that there's an SI symbol for quantity of oxen, but we have 4 of them, so we'll just write that down. And then we were also told that we have 1 ton wood, and we were given the joule equivalent. 1 ton wood is equal to 9.83 times 10 to the 9th joules. So what we were asked to do is compare the two, and I think the easiest way to do that is just calculate the energy output of the oxen. So I'm going to find E ox. So in this case, E ox, you kind of got to use your brain here. There's 4 of them, so I'm going to find the energy output of 1 of them and multiply it by 4 to find the output of the team. So it's 4 times P times T. That should be a capital P, excuse me. Right? It's not the formula we've been using, but there's 4 oxen, so hopefully that makes sense. The oxen were 0.8 horsepower each, and they were available for 1,200 hours. So if I multiply that out, 4 times 0.8 times 1,200, I get 3,840. You can see the units are going to be horsepower times hours, which is just HPHR, horsepower hour. Unusual, but not wrong. I do need to convert that over to joules next so that I can compare it to the energy density or energy content of 1 ton of wood. So if you go into the textbook, you'll find out that The conversion between horsepower hour and joules is 2.685 e to the 6 joules per HPH. And so the oxen is going to be 3,840. Some people write this HPH, some people write it HPHR. Hopefully you're paying enough attention that that doesn't confuse you. Then we'll just throw in that conversion factor from the textbook, 2.685 e to the 6 joules for every HPH. And so I got 10.31 gigajoules. Right? What is a giga? Remember, it's kilo, mega, giga. 10 to the third, 10 to the 6th, 10 to the 9th. All of those are really commonly encountered in power systems. So we've got 10.31 gigajoules. EOX equals 10.31 gigajoules. And it was 1 ton of wood, and 1 ton of wood is E wood. We can see from up here we had 1 ton of wood. We were told that there's 9.83 times 10 to the 9th joules. Well, 10 to the 9th, hey, that's nice. That's a giga. So E wood is equal to 9.83 gigajoules. All right, so the oxen, just a hair more. 1 ton of wood is roughly equivalent to a team of oxen working over the course of a year. Would be handy if you were a settler in early America, perhaps.